Ted Blackman here is a hacker at 3Scan, and he's going to be telling you about slicing brains with Meteor.
Hi there. My name is Ted Blackman. I'm with a company called 3Scan. Let me see if I can blow this up a bit. So here is 3scan.com. We make microscopes that do what we call serial sectioning microscopy. So it's a little bit like a 3D printer running in reverse. What you do is you give a cubic centimeter or so of tissue, brain tissue or other tissue, put it into the microscope, and it slices off the top. And as it slices, it has a line scanning camera that images the slice. And then we do this over and over again until we've consumed the sample, slicing it about 1 micron thick. And then we can do a 3D reconstruction and get to data like this, where you can see this is a data of the microvasculature in a mouse brain. You might be wondering where Meteor fits into this. A lot of people do. We use Meteor for the control. So to actually control the microscope, let me blow this up a little bit too. Or not. Here we go. OK, so this is the user interface for controlling the microscope. There are a number of settings over on the left for controlling the bounds of the sample. This is actually running all locally on my machine. And so that's why it says sim up in the top. So if I go ahead and click slice face here, then if this all works correctly, you'll see this is a representation of the knife slicing across the top of the sample. And so this is just a simulator. But here's the actual interface to the real device. And on the real one, you can see that there's these images here. And these are representing the data that we get off the machine. So these actually populate. This is using a library called Leaflet, which provides something similar to Google Maps, where you can zoom and pan around. And so as you're running the microscope, there will be these new ones that pop in, new strips of data. And one of the interesting things that we've done, similarly to the earlier talk about the Java DDP client, is that we actually have a cluster of machines that are all running worker processes. So here we are. Each of the 4 brain slaves. So this is a process manager that we wrote using a Python DDP client. So each of these machines has a process supervisor that maintains a DDP connection to the Meteor server. And it is told which processes it's supposed to run. And it also reports a number of statistics back, like the CPU and memory usage, and whether the processes have crashed and how many times they've crashed. We do continually break this. And then you can add a new process onto a machine, like so. So now that just by dragging it from the left onto brain slave 0, we now have that process running. I'm going to kill it because we don't actually want that running long term. So the way this works is that each of these machines is actually a Meteor user. So it authenticates using Meteor's auth system, and then registers itself. And so we can just dynamically add machines to our cluster as we install them. Thanks. There you go.
Questions?
Where can we get your Python implementation of DDP?
If you go ahead and email us, you can email ted@3scan.com, or sorry. The question was, where can you get the Python DDP client? We haven't released it, but if you email us, we can send it to you probably. We just haven't gotten around to open sourcing it really. One thing we did recently that was pretty cool was we implemented DDP Reconnect, which was a lot harder than it sounded. Yeah.
So you say you're actually using Meteor to control the scalpel?
Not directly. So we use Meteor for the, oh, sorry. The question was, are we using Meteor directly to control the knife?
I mean, not directly, but to communicate between the robot?
Yeah, sure. I'll give you a very brief overview of the sort of topology of the system. There's the Meteor server, which serves this website, which is the user interface. I can click a button here, which sends a Meteor method to the Meteor server. And then that Meteor server communicates with what we call the KESM process, the knife edge scanning microscope process, which is this one here running on a different machine. So that's the machine that actually has the stage and the camera attached to it. And that's a Python process that controls the actual hardware interaction. But then it maintains a DDP connection to the Meteor server and receives commands and reports back data. It also, once it gets an image, so it gets an image about once a second, and it's like 4,000 by 12,000 pixels, something like that, then it shunts it off to the receptionist down here on another machine, which is basically the load balancer, which then distributes it out to one of any of these image tiling and image compression processes on these other machines, because we store the images actually locally in a big RAID array, and because it's just a lot of data, and so the images have to be compressed. It's a lossless PNG compression, and then also they have to be tiled into much smaller pieces so that we can have this this kind of user interface. These images here are actually made up of many tiles of smaller images. So once those tiling and compression processes finish, then they go and talk to the I/O thread, which just writes it all to disk. And it's important to write it all sequentially, it turns out, because as Matt, my colleague, is very fond of saying, it turns out that at some point computers are just a bunch of spinning rocks. And so you really want hard drives to write like this, not like this. Does that make more sense?
All right, thank you.
Thank you.